Hi guys, welcome to the next lecture. So today I will be talking about integration using partial fractions. So integration by partial fractions. Okay. Now you consider a rational function, a rational function px upon qx. A rational function px upon qx, where qx is not equal to 0. Where qx is not equal to 0, if the degree of px, every polynomial is of some degrees, so if degree of px is less than the degree of qx, then the rational function is called proper, otherwise improper. Is called proper, otherwise improper. Okay, now what happens is that improper can be reduced to proper. Improper can be reduced to proper. Improper can be reduced to proper by long division method. Division process. So what's going to happen is your px upon qx, when it is improper, that will turn out to be, with long division, some function tx plus some p1x upon q1x. And this p1x upon q1x, not q1x, sorry, just qx, p1 is a new function in the numerator, p1 upon qx. This will be actually proper. This will be proper. So initially, if px upon qx is improper, now when you use long division and convert it, this is what you will get. You can get a proper. Now it's always possible to write. It's always possible to write the integrand as a sum of simpler rational functions by a method called partial fractions. Partial fraction decomposition. So what is this decomposition all about? So what is this decomposition all about? If you have, say, so I'll just mention all the possible cases here. So let's just mention all the possible cases here. So suppose case number 1, if you have, say, px plus q upon x minus a into x minus b. where A is not equal to B. This could be written as A upon x minus A plus some B upon x minus B. Similarly, suppose you have a case where Px plus Q upon, you have say x minus A square. Then that could be written as A upon x minus A plus B upon x minus A square. Suppose you have Px square plus Qx plus R holding upon x minus A into x minus B into x minus C, that is equal to A upon x minus A plus B upon x minus B plus C upon x minus C. And number 4, if you have Px squared plus Qx plus R upon x minus A whole square into x minus B, that will be equal to A upon x minus A plus B upon x minus A whole square plus C upon x minus B. And number 5, Px square plus Qx plus R whole upon x minus A into x square plus bx plus c is equal to A, that can be written as, decomposed as A upon x minus A plus bx plus c upon x square plus bx plus c. Now with examples, of course, you'll be clearer. These are generalized forms, so you will be clearer when we actually work with some examples. So let's just start doing that here. So let me just take up some examples for you guys. So example 1. Let's solve the integral dx upon x plus 1 into x plus 2. As I said, I can write this, I can decompose it. 1 upon x plus 1 into x plus 2 could be decomposed as A upon x plus 1 plus b upon x plus 2. And if that is the case, you need to figure out what will be A and what will be B. How do you figure that out? So what we can say is that after taking the LCM, I can say that 1 is equal to x plus 2 times A plus x plus 1 times B. Now let's compare the coefficients. So let's compare the coefficients. Equating the coefficients, what will I get? The coefficient of x is 0 here, and here it is A plus B. The coefficient of constants, basically the constant here is 1, and here it is 2A plus B. Can we solve these two equations? Absolutely we can, right? So solving these two equations, what I'm going to do and what I'm going to get is, if when you subtract, and you will get that A is equal to 1. And the moment you have A equals to 1, that implies B is equal to minus 1, right? So that's what you can do. And that means the integral 1 upon x plus 1 into x plus 2 is equal to 1 upon integral of 1 upon x plus 1 minus 1 upon x plus 2, right? So integral, we can take it inside here. So dx here as well. So this will become integral 1 upon x plus 1 dx minus integral 1 upon x plus 2 dx. And that will give you log x plus 1, natural log x plus 1 mod minus natural log. So guys, when I'm writing ln, that means natural log. This is how it is written. X plus 2, mod x plus 2 plus c. So you can also, since it's log and when you're subtracting, so you can write it down in the denominator. So you can also combine the two and write down it's x plus 1 upon x plus 2 plus c. Okay. So that's what it will look like, the answer. And that's how you use the partial fractions. Now let me take another example of different kind. Let me take an example of the kind x square plus 1 upon, so we have to integrate, x square minus 5x plus 6. So what did I mean by long division when I said all those things to you, the generalized form? So what you can do is you can just divide. You can divide x square plus 1 by x square minus 5x plus 6. And as a result, what will you get? So you will multiply, when you get x square multiplied by 1 will give you x square. So you get x square minus 5x plus 6. When you subtract, this cancels. This is plus 5x. So you'll have 5x. Right? You have minus 6 and plus 1 from above. So basically what do you have? You have 5x minus 5. Or in other words, what I can say is that x square plus 1 upon x square minus 5x plus 6 is equal to 1 plus 5x minus 5 upon x square minus 5x plus 6. Now, integrating 1 is very simple, right? So integral, would be integrating on both the sides. So integral dx would be integral of this, right? So what is important for us is this portion, because integrating 1 is very simple, right? So what we can do is we can work out with partial fractions on this integral, say I1. So I1 becomes integral 5x minus 5 upon x square minus 5x plus 6. And using the partial fractions, I will get 5x minus 5 whole thing upon x square minus 5x plus 6 is equal to a upon, do you know what are the factors for this? Clearly, can you see the factors here? Clearly, x minus 2 into x minus 3 gives you the same thing, because the product is 6 and sum 5. So this will be a upon x minus 2 plus b upon x minus 3. This is what you will get here. So 5x minus 5 is equal to x minus 3 times a plus x minus 2 times b. Taking the LCM, again, we will compare the coefficients. So what you can see is the coefficient of x is 5 here. The coefficient for x is 5 here, and it is a plus b here. And the constant term is minus 5 here, and here you have minus 3a minus 2b. Minus 3a minus 2b, right? Or in other words, minus minus can go off. Now, having said that, you can eliminate and figure out one of the variables and then figure out the other variable. So what I can say I can do is, let me just change the color. What I can do here is, I have 5 is equal to a plus b. Now I can keep this as 5 is equal to 3a plus 2b. So I'm going to multiply this by 2. I'm going to multiply this by 2. So this getting multiplied by 2 implies I have 10 equals to 2a plus 2b. And here you have 5 equals to 3a plus 2b. So subtract and this goes off and you will get a is equal to 5. 10 minus 5 is minus a. So a is equal to minus 5. A is equal to minus 5 clearly. A is minus 5. So what will be b? B will be 10. 5 plus 5, that is 10. So that means this turns into the integral I1 turns into, or maybe we can just talk about the entire integral. The entire integral turns into integral of 1 dx, integral of 1 dx, plus integral of minus 5 upon x minus 2 dx, plus integral of 10 upon x minus 3 dx. So hence it will be just x here minus 5 log x minus 2 plus 10 times log x minus 3 plus a constant, right? So that is what it will look like. So these were a few examples of partial fractions. I'll give you some more examples in the next lecture.